When I say that Pynecone comes with batteries included, I mean that it has an easy-to-use database ORM that takes care of some of the building for you. Since this built-in ORM wraps SQLAlchemy, it is already familiar to most Python developers and supports connections to these database management systems. But you can feel free to extend the capability of the library or design your own query logic. You configure your connection in pcconfig.py file by assigning your database location to the DB URL. By default, the configuration points to Pynecone's included SQLite database. SQLite is suitable for most applications until you get something like over 100,000 page views in a day, so for simplicity, this is what I used for RAPL. To make a table for your database, define a class that inherits from the Pynecone.model class and specify that it is a table. Remember to type hint appropriately. From then on, every time you run your application, Pynecone will check if your table exists and creates it if it does not. If you aren't familiar with tables, they are the objects in the database that contain all of your database data. You could think of them similar to a spreadsheet where each column represents the attributes in our table class, and the rows are unique records in that table. In RAPL, we have three main tables. One table holds all the possible songs and lyrics. Another table holds the song of the day and previous songs of the day, and the last one just logs user performance into the database each day. To access the database, we use sessions by calling Pynecone.session, which will open and close your connections for you. These calls will be placed in your state logic just like the rest of your backend code. Feel free to make a subclass as explained in the state tutorial to organize database actions into their own namespaces. I use one here in RAPL to clean up my code. With our session object, we can create, read, update, and delete records from our database, and use our data to power our application. This is where ORM really shines, as you do not have to learn SQL queries. You use built-in methods and arguments that write the SQL statements for you. For queries, refer to the SQLAlchemy Legacy Query API to see all of the possibilities. I'll highlight two of the most useful Pynecone examples. I like using the query.filter method, which allows you to narrow down your results according to the attributes defined in your previously defined model class. It's easy to throw in a boolean and get the results you want. Another is the .orderBy, which allows you to return results in the order of columns, such as alphabetical by artist, and within that, by song title. After using queries that modify the table, such as session.add, session.update, or session.delete, ensure to include session.commit to reflect the changes in our database. Between commits, your modifications make up a transaction which will run all at the same time at execution of the commit. This prevents partial changes from occurring when one piece of code works, but another part does not, and it prevents the database from modifying data that has since been changed by another transaction. In RAPL, each time a new user visits the application, the daily song getter runs. This code accesses the database via session and starts with a query looking for today's song using the Python datetime module. If it finds a song, then it sets app state to the fetch song. However, if that user is the first user of the day and no daily song exists yet, then it will query all the possible songs and returns a random song. To avoid having the application repeat previously used songs, I placed a check based on a unique song ID that will call itself again if the song has already been used. Once the song is selected, it is added to the daily song table, and the song function calls itself again to the set today's song to the app state. As for the performance tracker, the application simply adds a record to the performance table each time the game ends, with the date and how many guesses the user used. If you like this explainer, like and subscribe for more.